from Case Western Reserve University, Cleveland, Ohio, USA, in 1990 with a Bachelor in Electrical Engineering Power System. He obtained his Master in Electrical Engineering from UiTM Shah Alam and his PhD in Electrical Engineering from University Kebangsaan Malaysia in 2003 and 2011 respectively. He also did several business management programs with Harvard Business School, USA. Professionally, he is a member of Institute of Engineers Malaysia, IEM, and is a registered professional engineer with practicing certificate with Board of Engineers Malaysia. He is a senior member of IEEE and member of IEEE Power Energy Society. He is also a member of CIRAD Malaysia. His areas of expertise are power system operation, power system protection, power system simulations, voltage stability, transient stability, power quality, reactive power compensation, arc flash, renewable energy, energy efficiency, signal processing, and machine learning. He holds technical certificate for competent electrical engineer, supervising electrical engineer and registered electrical energy manager from Energy Commission Malaysia. He is also involved in the development and evaluation of technical standard with the Department of Standard Malaysia, IEC and IEEE. Without further delay, it is my pleasure to invite Dr. Muhammad Fuad bin Faisal to deliver this webinar titled Power Quality Industry in Industry. Power Quality Issue in Industries. Over to you, Doctor.
Okay, thank you, Dr. Dalila. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning. First of all, I'd like to say thank you to Dr. Dalila, Dr. Fauzi, for inviting me to give this on power quality. I would like to also say this is going to be a sharing session by me with all the, I would say, the participant from UTM on power quality. As mentioned by Dr. Dalila, I've been doing this power quality aspect for TNB and for the industry for more than 22 years. So today I would like to share my experiences. I would like also to welcome questions related to my presentation, as I will, because the topic itself is very vast and there are many technical standard, technical requirement and regulation related to power quality. So let me now share my slide with all participants. Okay, can everybody see my slide?
Yes, Doctor, we can see.
Okay. As mentioned by Dr. Dalila, I will be sharing power quality issue for industries, and these are basically the current requirement in Malaysia and also most part of the world in managing power quality. So what I will do, I have listed down a few content for presentation, and I will do my best to share with everybody on power quality issue and also on mitigating requirement. This presentation will be very brief because it's only a 1 hour session. I hope I can do my best to share with all participants on the topic of PQ and the recommended mitigating measures. My contents will be as follows. First of all, as mentioned, power quality is a practical issue. I agree, it's also a very good topic for study, research, etc. But it is also a very important issue for customers. So on the first point of presentation, I will share the importance of customer and product quality, because as we know, electricity is a product, and customers require product, and customer satisfaction is related to product. Secondly, I will share the definition of PQ. I believe most of you have heard this before, but I will try to share in the perspective of power utility and customer requirement. Number three, I will share the concern. Why I would say customers or maybe industries are upset on power quality. So number four is impact. So the concern on PQ will be followed by what is the impact on of PQ to business, industries, customers, and even to manufacturers. Number five, what are the recommended mitigating measures? These mitigating measures is related to regulatory and also to the standard bodies. As I mentioned just now also, I would like to present something practical because I think most of the participants here have already experience in your jobs. You have you worked before. I believe you are doing your master or PhD. So for people like us, we are born to standards of based on our working experience or working requirement. So we must follow the standard. Next will be the regulatory. So for Tenaga Nasional or power electric industry, we are born to regulation. In Peninsular Malaysia, we are being monitored by the Energy Commission. So these measures must comply to the regulatory requirement. And lastly, I will open for Q&A. Okay, let me start by sharing on the first point of the presentation on customers. So for industries in particular, we must have customer. So to have customer, we must have a product. So I'm sharing you now a very famous dish in Batupat. Why I'm putting Batupat on the map because I was working in Batupat for almost 8 years, and one of the delicacy there is called mi racun. I believe those from Johor, they're aware about this dish. So these dishes, the mi racun, actually Batupat has a lot of more dishes like nasi biryani gam, Muhammad Shah. I think a lot of dishes that are very tasty. And I remember again the nasi lemak, nasi goreng Senggarang, very famous. But the mi racun is one of the dishes. So this slide is showing that there is a product called mi racun. For the product to be accepted by the customer, it must have certain quality. And then when the dishes is bought by customer, the seller has revenue. So if the seller or the customer manage to gain certain revenue, so as you know, for business prospect, revenue minus cost, you have profit. That's how a business survive. All businesses in Malaysia, you must have revenue to survive. So, but the revenue is attached to the product and services. If the shop is very famous, customer oriented, customer will always come to the shop to buy. But if the seller is very arrogant, maybe the food store is dirty, no customer will come. So these are all elements of quality. So for Tenaga Nasional, I put down the PU, power utility. Power utility means Tenaga Nasional. Kalau for example in Sabah we have SESB, Sabah, Sarawak we have SEB. You are in Kulim, we have Nol Kulim, etc. So for power utility, the product is electricity. So means that if you compare electricity to a food dish, like mi racun, you must have customer to buy the product, And then the customer must be very happy with the product so that the revenue can be obtained by the company. So PU is utility or power utility. So this next slide is showing you the customer satisfaction. So the topic of today is power quality concern for industries. So industries mean customer. So if the customer is not happy with your services, with your product, so the business would be very bad condition. For example, again, the mi racun dish shown in this photo. If the food is very good, people will go to the shop and buy food. So there will be revenue. Customer is satisfied. In regard, or maybe on the other side of the coin, if the food is not good and the service is bad, and then also expensive, people will have second thoughts of going to the shop, and this will affect the revenue for the customer. For electricity, as I mentioned, I think everybody is aware about this. Electricity is an essential. So it's a very important product that help us to operate our computers, our television, our equipment, etc. Without electricity, things will be very difficult. We need electricity to run our aircon, lighting, fans. So for Tenaga Nasional or power utility, our product is electricity, or in simple term would be the voltage, is shown on the screen. As with the voltage, you have electricity, and then you can operate your machine, etc. So the way voltage is portrayed is by recording the waveform. So you are seeing on the screen now the voltage waveform, or as we learned in high school, sine wave, voltage sine wave. So the red the sine wave is the voltage waveform, and then the blue line is voltage RMS. So RMS is another way to depict the value of the voltage for electricity. And then you can see below the slide, there's a lamp blinking, and the frequency of the voltage in measure is 50 Hertz. So these are the product for power utility. So if the product is available, customer consume the product, then customer will pay for the product. So this will be revenue for the utility, in this case, Tenaga Nasional. For the awareness of all participants, the product for power utility is voltage, and voltage is shown as a voltage sine wave. But to better get a simple value or simple understanding, voltage is displayed as RMS value, root mean squared. Means that all the data on the waveform must be squared, and then you must sum the squared, take the mean. The mean is depend on the data on the waveform. Then you square root that mean, you have RMS value. So RMS value is the value steady state voltage for the system. And as you can see on the slide, I am showing you the original power flow for utility. Later on, I will explain why I mentioned the original method. So originally, electricity is generated by the power plant. So power plant, you have a combined cycle plant, gas turbine, etc. So electricity is generated by generator to voltage of 11 kV. And then this will be at the power plant. In Johor, we have a lot of power plant in Pasir Gudang, Tanjung Bin, etc. And this voltage 11 kV RMS, not sine wave, RMS value, root mean squared, will be transformed into higher voltage up to 500 kV, from 132 kV, 275 kV, 500 kV. This is for transmission. As you know, most power plants are located, I would say, the outskirts, or maybe near the sea for technical purposes, so that it will be a very safe and suitable location for the power plant. but this voltage must be transmitted. So that's why the voltage is transformed to higher voltage to reduce the losses at 132 kV, 275 kV, and 500 kV. And then this transmission line, as you can see this transmission line, big towers along the highways, along the maybe kampung side. So all these towers are transmitting voltages or electrical power from the power plant to the load area. Load area is the city center, or maybe places we have people around. So at the city center or the commercial area, the voltage is then stepped down to distribution voltage of 11 kV, 22 kV, and 30 kV. And later on, this voltage will be further stepped down to the low voltage side for customer consumption. So all your houses, hostel, will be taking at the low voltage side. So this is the, I will say, original power flow from the generation, transmission, distribution, and the customer side. This is how power originally is generated, transmit, and distribute to customer. I have just now defined products of electricity, or maybe I will say for Tenaga Nasional, the product is electricity. Electricity is also, I use the term just now, voltage. We monitor the voltage level to determine the product for the customers. Now, I would like to further explain on power quality. I remember just now I showed the slide about mi racun. So if a customer is happy on mi racun, or you go to Batu Pahat, you will see nasi lemak, nasi biryani, gam, Muhammad Shah. You can see a lot of dishes in Batu Pahat. So if you are happy with the product, you always will go to the shop and buy more. You also bring your family, your friend, because product is good. And I believe that it's cheap and the shop is very clean. So the same goes with electricity. There is an element of customer satisfaction. Is the product quality? Is the product efficient? Is the product or services good? How about the value? And on-time delivery. So these are all elements of quality for customers. We are all customers. I'm also a customer. We want to be treated very well. So either it's electricity product, or you go to a shop to buy food, to buy handphone, or maybe you go to fill up your car at the petrol kiosk. So you all want services from the seller, and then you also want quality services product. So now for electricity, it's the same. We must have the element of quality of the product. What you're seeing now, the element of quality for electricity. The first one is called normal power. Is what we're having now. You can view my slide. You can hear I'm talking just now. You hear Dr. Dalila. Means that you're having normal power. Means your lighting is working very fine. Your computer, your Wi-Fi, etc., is operating because there is a normal electrical power for your premise. So it's called normal power, and customer are happy. Customer want normal power. Okay, but at the same time, for B, sometimes the quality of the power supply is lesser. So you have under voltage, where light will very dim, fans will rotate very slow. I believe some of you have explained this before, either in your kampung, where voltage is lesser. Okay, next one will be over voltage. This is quite critical. The light is very bright, fan rotate faster, and severely, it can damage your television, etc., or computer. This is called over voltage. And the number D is called outages. This is I think everybody have experiences. No electricity, blackout, it will last more than 6 seconds. So now let me in brief share this four quality of power element with everybody. This is a few news clipping on the four item. Normal power is what the industry wants, customer want. Under voltage, as you can see on the slide, this is some article I copied a few years back about low voltage in Batu Pahat. And for over voltage, this an event occurred, I believe, in 2012, where over voltage occurred because the television had one shop to explode. And for item D, outages, you can see there's few news clipping. The most famous one was in 1996. You can see our former premier Tuan Mahathir in Langkawi, and then in Kepong of the power outages, and causes of the power outages in Selangor. These are the data improper. This is very important. Apart from learning from me, this is also relevant to yourself. If you encounter this kind of scenario, according to regulation, you must immediately report to TNB, because TNB is under, I would say, being monitored. So if customer experience under voltage, so you can see here now a photo of a climb meter and also a voltage showing voltage of 205. So by that, all domestic customers single phase must receive voltage of 230 to 240. So if you have lesser, you must complain to the utility. If you are in Sarawak, SCB, because this is very important. Because imagine, we're talking about customer satisfaction, and then product quality. Product is not quality here. If you are a part-time student, you are working with an industry, remember, at 11 kV, the voltage must be 11 kV plus 5 minus 5. If your industry is experiencing 10.2 kV, this is under voltage. This must be reported immediately for action to be taken. If you are working with industry or taking LV 400 volt, as you can see here, the voltage shown is only 313. So it's lower than the value. So on my slide, I'm showing the ranges for the voltage from LV, 3-phase 400 volt, single phase 230 up to 275 kV. If you have lower voltages than this or voltage exceeding this value, you must report, because this is the quality of the voltage. And as customer, you have the right to make complaint because you are not happy with the voltage. Next, over voltage. This is the higher side of the voltage, which is not allowed. Again, we're talking about power quality, but there are, as mentioned, there are regulations required by the regulator for utility. So if you are experiencing, you can see on my right hand side, on the top of the slide, you can see a socket tester showing voltage of 288. This is over voltage. So myself as engineer, and TNB engineer, I have a lot of gadgets. For example, the socket tester you can see on the slide. I have around 7 of these. So I'm giving my children one of them, all of them one unit, for them to test their own rooms. If they are experiencing low voltage, they have a meter there showing low voltage. If they have over voltage, it will show the value there. And even if my son having wiring problem in his room, the socket tester will help them to identify. That's how I'm teaching them. But anyway, for all of you, this is a good gadget. I'm not selling this product. I'm just sharing. The socket tester is a good product. As when I joined TNB in 1991, as a new engineer, I was given one of these tester, but the old version, this is the latest version. Because as an engineer, you know that electricity can kill. You cannot touch electricity. You must have some equipment to test the voltage. Okay. If the voltage exceeds this value, it's over voltage. And if you're working on the 11 kV system, you are experiencing 11.73 kV, this is over voltage. So you must report to TNB. And then your equipment must be switched off, or else it might be damaged. And if you're working with LV 3-phase 400 volt, if the voltage exceeds 156 volt, this over voltage. You must switch off, report to TMB. This is very, very, very important because it can damage the equipment insulation. And on the lower left-hand side of my slide, I'm sharing the same table of voltage limits. That's very important. So if you are experiencing voltage lower or upper of the limits, you must report to the utility. For Peninsular Malaysia, it will be Tenaga Nasional, but looking in Sabah, it must be Sabah Electricity Supply Board. You're working in Sarawak, it must be Sarawak Electricity Board. Okay, next I'm showing the news clipping on outages. As mentioned, the famous, I would say infamous outage in 96 in Kedah area. And then I'm sharing with you the 3 dates that have caused outages, major outages in Peninsular Malaysia. The first one was in 1992, 31st July. Second one, 3rd August 1996. And the last major event was in 4th September 2003. Means that it affected the whole peninsula, and it took a few hours to restore supply. So everybody, the whole Peninsular Malaysia experienced this. If you are working at this time, or maybe you are in school during this time, I think you will remember these 3, I would say, infamous dates that caused power outages for the whole Peninsular Malaysia. This again, bigger showing of the outages in Selayang. Okay, now I've just now explained the quality of power on under voltage, over voltage, PQ. Now I'm sharing on power quality. So power quality is also part of quality of power supply. So here it's very important for us to understand. When we talk about quality of product, we're talking about quality of power supply. There are basically 5 elements of quality of power supply. This is being monitored by our regulator, Energy Commission. So the last element of quality of power supply is called power quality. So you can read it from my slide. The symptom, the light will blink. Some equipment will stop. Product will be damaged. Some product will be overheating. And UVR stand for under voltage relay operated. Okay, LCD is best understood or maybe studied by the waveform. As mentioned, I mentioned just now, the product is the voltage waveform. The voltage waveform is a sinusoidal waveform. So if the voltage waveform is perfect, we have normal power. If the waveform is reduced, we have under voltage. If voltage increase, reduce and increase for more than 6 seconds, we have under voltage and over voltage. But if the voltage fluctuate, for example, voltage set, it reduce slightly and go back to normal. The same goes for voltage swell. If the voltage slightly increase, then go back to normal. This is swell. As compared to over voltage, it will be permanent. As compared to under voltage, it will be permanent. For voltage set, it's only a short duration. The same also goes for voltage transient, as you can see on my slide. Impulsive transient, oscillatory transient. These are all very short duration, very short. The most common symptom, the light will blink. And then we have harmonics. As you can see, the voltage is no longer sine wave, but distorted. Followed by notching. There are some small transient there. And we have next voltage fluctuation. These are basically the main. There are more power quality disturbances. I'm showing you now the main power quality disturbances. There are more, but these are only the main ones. But okay, the most critical power quality disturbances is voltage side. So as you can see in my slide, the voltage is reduced slightly and return to normal. And I'm comparing now the sine wave and the RMS value. And you can see also the SMS. SMS, this is from TNB system. It will send SMS every time there is a power quality event. In this case, there was a voltage set event in Ampang. So the system is very sensitive. It will detect, classify, and diagnose the event. So PQ is the most important or critical event to customers. Okay, this is also very important for customers. Sometimes there is a misunderstanding between the definition of voltage set and voltage dip. So I'm sharing now a very simple definition. If the voltage is missing, it's called dip. If the voltage remain, it's called set. So, for example, you are drinking from a glass, drinking water from a glass. The water that you have drank is called dip. The remaining water left in the glass is called voltage set. So, it's very important for studies, for interaction with customers, for us to mention the right parameter. Is it a set or dip? You can see on the same slide, the SMS. This is a Nokia handphone. This is my old handphone. I still kept it to my Nokia. So it shows voltage. Remember, you can see that on the slide, the red phase is 83% is a voltage side. Means this is remaining voltage. The yellow phase 103% normal voltage, and then the blue phase 76.5 is remaining voltage side. So this voltage that remain during the event. So we just 100 minus this value, we have the dip. So these are the definition between voltage set and dip. And voltage set is used widely in America, IEEE, but voltage dip is used in Europe, IEC, etc. Okay, these are the common causes of set in Malaysia. As you can see, the main culprit would be lightning, and then we have animal, birds, that like to push on the power line, and we have excavation work, digging, and you can see also on the slide, trees, encroachment, trees touching the power line, and on the second level you can see crane touching power line. This is construction work. And the next one, due to customer equipment flashover, and the kite case, this happened in 2009. Okay, I have drawn a dark circle on the face of the boy. What happened in 2009 in Bandar Maju? This boy was flying a kite. So the kite accidentally grazed the power line, a 275 kV power line, and the boy was electrocuted. So you can see the father and the boy. So I blacken the face of the boy. The boy was electrocuted by the kite touching the power line. So my advice for our kids, our neighbors, maybe our nephew, don't play kite near the power line. So it's very dangerous if the power line and the kite touch. So it can cause electrocution. Okay, this is also a very important study done by I think many researchers on why every time the light blink, equipment will stop. There are basically three main causes. The first one, voltage that is very dependent on voltage magnitude. If for example, the equipment require 11 kV, but then when the voltage slightly reduce, it will malfunction. Okay, the next one is due to both, due to magnitude and duration. If the voltage reduce to certain duration, equipment will be affected. Okay, lastly, due to unbalance, as we aware, the power system is a three-phase system, and the red, yellow, blue phase are separated accordingly based on the angle. So during a voltage set event, there is a voltage unbalance that cause the point of wave issue monitoring, that for critical equipment will be affected by this element. Okay, just now I show a news clipping of on under voltage over voltage and outage. Now I'm showing the news clipping on power quality in a particular voltage dip. This is was reported in Penang few years back, where customer in Penang they are still angry. People yesterday we have power dip in Penang, last week, almost every week. So the customer association, FRIPENCA stand for Free Industrial Zone Penang Company Association. They are upset because as explained just now by the three issues, the three concern about the magnitude voltage, magnitude and duration, and phase imbalance cause critical equipment to be affected. And we are aware in Penang they have semiconductor industries and a lot of high-tech industries. And also in Penang, I believe Malaysia has the biggest semicon plant, which is Intel Penang, in Penang and Kulim. So every time there's a power dip, so the customer are affected. Okay, this has happened in Gebeng. As I think we are aware, Gebeng area is an industrial area. So although the newspaper reported outages, it's not true. It's really power quality. So I went there in 2006. Most of the plant there complain about the light blinking equipment trip. But to the customer, anything that trip the equipment is called outages. But as explained just now, outages is when the voltage goes to zero for more than 60 seconds. But for power quality, it happens less than 60 seconds. 6 seconds means permanent. So this is not permanent. This is a short duration event. Okay, this is also another news clipping. I put up the photo. So customers complaining about their circuit board, their wiring circuitry being damaged by over voltage. So this basically due to lightning strikes. So lightning strikes can damage sensitive equipment. Okay, this is another report about electronic capacitor failure. So this is a very, very real issue in Malaysia in particular, because we have lightning, and then we have semiconductor industries, and later on I will share about the impact of this RE electronic gadget that cause harmonics. So sensitive equipment are very sensitive or prone to harmonics. Okay, this is a newspaper article from overseas in Brazil. So from the newspaper itself, after the firemen extinguished the fire, there was a study done. So based on the report that I've read, they said that the transformer overheated due to harmonics. That's what they reported in the newspaper. Okay, this is somewhere near to Malaysia. Power capacitors explode due to over voltage and harmonics. So as you can see, there's a hole in the capacitor can on the left hand side. The right hand side, you can see that the bushing of the capacitor can are broken, burn, missing. All these are due to harmonics. So I believe Dr. maybe later on can share with the student the impact of harmonics on capacitor, in particular parallel resonance that can damage the capacitor. Okay, this is just an article I read recently about the issue of power surges, especially due to lightning. So lightning is also power surges or transient is power quality event that can damage your domestic appliances. Okay, now I will share the concern on power quality by the industries. Okay, the first concern, this is, I believe, everybody is very familiar. Previously, most of the equipment, I will say, based on electromechanical design. For example, our maybe wall, clock, wall on the clock, they're all basically electromechanical. So every time there's a power dip, there are transient, no issue to the controller of the fan, all the electromechanical. But as we progress, due to the semiconductor age, fiber, etc. So all these equipment are very, very sensitive to power quality. Due to noise, I didn't mention about noise, transient, harmony, they are very, very sensitive due to their design related to power quality. Okay, all the semiconductor electronic devices are being used widely in university, hospital, commercial building, and also industrial plant. These are very, very true. If you go to hospital, we have the MRI machine. Currently, I'm studying MRI issue in hospital cancer Putrajaya. So they have a problem with MRI. Every time something happens, MRI will stop. So this disturb the hospital operation. So because of the change in technology, the impact on equipment operation is quite critical. Equipment, I believe in Johor, you have I remember the company like Seagate, Seagate in Senai and in Skudai, Western Digital in Pasir Gudang. Those are very sensitive. Even Hospital Sultan Aminah in Johor, all very, very sensitive to power quality. So these are the concerns on power quality. Okay, just now I mentioned the word originally power flow as I believe I think in most textbook the old textbook lah, maybe during my time we are only exposed to the concept of the one-way power flow. Means that the power must be generated by a power plant or mini hydro, etc. And the power must be transmitted by a power line or the pylon tower. Okay, just to share, in Malaysia we use the lattice tower quite a lot in Peninsular Malaysia, and then this power is transmitted to a main intake substation. This is called a substation that step down the voltage to lower voltage, and lastly the power is distributed to a substation. So from the substation, I believe there's a lot of substation in UTM, even maybe your housing area. The power is step down further lower voltage. This is the original one-way power flow. I would say one direction. But you have heard the government announcement, government announcement on low carbon, net zero carbon, and then I think recently the government announced the target of REN, renewable energy, of 25% by 2040, if I'm not mistaken. So what this does, it introduces a concept of bidirectional power and the concept of distribution generation. Previously, as mentioned, originally the power is generated upstream near the power plant or at the power plant. But the current technology, the current initiative by I would say certain company expert or big industry, they have introduced the concept of distributed generation. So in Malaysia, I believe maybe even UTM, I think we have you have your I think integrated photovoltaic system BIPV, or maybe you have large scale solar. So all these are technologies that focus on renewable energy from the sun to be transformed into electricity. So this is distributed generation technology. So apart from the solar, there also biomass, means that all the palm oil, I would say the leftover, maybe the palm leaf, the husk, everything, and even rubbish can be recycled or burned to heat up the water, the boiler, and turn the generator. This also is called renewable energy. So their location is at distribution level, not transmission level. Okay, and then okay, for the wind farm, so far there's only one in Terengganu. It's a small scale. Okay, and then mini hydro, there's a lot mini hydro. owned by TNB and also by non-TNB. These are all connected at distribution level. So this is the new concept of power flow. Is called the bi-directional power flow. So I believe maybe some of you have put solar on your rooftop. So you are either FIT. You can see on the top of my slide, FIT in tariff means that everything that you generate from your solar rooftop, you will sell 100% to TNB. But as you aware, the scheme is no longer available. The government in 2007, I think, introduced NEM, net energy metering. Means that you put solar on your rooftop, you register with TNB, means that you will generate your own power, consume, but the balance will be sent to TNB. So this will be recorded as credit. So every month, for example, you have this credit, it will be deducted from your bill. So this is the NEM, net energy metering method. So this is the current scenario for Malaysia. But again, the connectivity is to TNB system. So as mentioned again, previously the power is generated at the power plant, but now it's generated at the lower side. So this is called bi-directional. So TNB install a meter that monitor the power from TNB, also power from the customer. So it's a bi-directional meter. Okay, next you can see on the slide also the concern on microgrid. So microgrid is true, means that I good example will be KLRA. KLRA has around I think 40 megawatt cogen, so that they will import from TNB on 10 megawatt. The system is self-sufficient. So if anything happen on the power line, they can be islanded, they can run by themselves. This is the concept of microgrid. And then I think we see on the low of the bottom part of my slide, electric vehicle. So these are the challenges for power utility in the coming future. Okay, the concern now, first of all, for customers, as we know, although Malaysia is I would say is a sunny country, but sometimes we have cloud, dark cloud moving by. So whenever there's a full sunlight, the solar panel can generate electricity, can inject to the power line. But whenever a dark cloud pass by, there will be no sun. So there will be no power generation from solar. So what this does slightly, it causes the power to light, the voltage to flicker. They flicker. So the flicker, normally you can see the light flicker, and then for critical equipment, if very critical, it will be affected. That's the concern. And then you can see also my slide, battery storage. Power is stored at night, used in daytime during peak load, or maybe the customer install battery storage to store power from the large scale solar, or maybe the battery is part of the large scale solar. These are all AC/DC conversion. As we are aware, when this happens, we have harmonics in the system. So these are the concern, the new concern for power utility, and also concern for customers. Even the electric vehicle charging. I think most of us aware when we fast charge something, or maybe we start a big motor, we can see that the light flicker. So the high flow of current to charge the vehicle or to jump start the motor will cause the voltage to fluctuate. So on large scale, this is a concern on for TNB and also the customer. So the customer is very will be impacted, because as mentioned just now, most of the customer equipment is now, I believe, more electronic or semiconductor based. So it might have an impact to the customer side. So these are the new concept of power quality. Okay, the existing concern on power quality is lightning. I think already aware for the last few weeks, even today, Malaysia is still exposed to heavy rain, whether it caused a massive flood. anticipating, concern to our nation that live in Shah Alam. Even my area, Ulangan, they also exposed to bad weather, heavy rain, kadang side, flash flood. Even my area also sometimes flash flood. Okay, for probability, when this kind of scenario happen, especially lightning will strike the power line. As we know, lightning can damage our astro recorder, computers, telephone, etc. So it causes the voltage to have transient event. So voltage will increase immediately, then it affect the equipment. So the customer equipment can be affected. The same goes for TMB. When lightning strike a power line, despite having lightning protection system like tau floating resistant, earth wire, it will cause the voltage to fluctuate. So we have voltage sag. That's why you're working in industry. Sometimes we have information from TMB saying that the cause of the voltage sag was due to lightning. So it's true. This is due to back flashover. Okay, this is a map showing you the number of thunder days in the world on lightning. So Malaysia is in the dark areas. So we are exposed to 140 to 200 thunderstorm days in 1 year. So in 1 year we have 365 days. So just wonder the frequency of the lightning event and also the transit event in Malaysia. Okay, that's basically the concern on power quality. Now let me zoom further into the industries. So for industries, power is very important for their production. Even in hospital, it's very critical. For example, last week, there is a power quality event that affect hospital Mount Austin in Johor Jaya. So the impact is that the equipment cannot operate. So we take some time to restore. But at the time, there were many patients in hospital. So the impact is quite critical. So unexpected power supply failures, circuit breaker will fail, will trip, fuse blowing, and some equipment will malfunction. Some cases, like I mentioned just now, in Malacca, we have cases of customer transformer overheat, trip, because of the harmonic issue. And sensitive equipment is quite critical because most control systems are semiconductor or electronic based. They are very prone to lightning. And then communication interferences is also an issue. And harmonic cause losses, I square R. Because I increases, it cause increases in losses. It's also a concern for data center, etc., that have a lot of DC AC conversion with that, because with the harmonic in the system, it require they need to oversize the equipment so that the conductor can carry the fundamental current plus the harmonic current. But again, the best practice is to minimize the harmonic. There are also penalties. This is also, again, regulation. If the customer impose harmonics in the system, cause flicker, there is a clause for disconnection. But it's very sensitive to implement this method. And then connection and refusal of new site. This is also concern on steel mill. But again, there must be a way out of this by following the regulation that the customer must install certain harmonic filters to ensure harmonic won't be introduced to the power system. This is data taken from Europe. This is a study way back in 2010, I believe. They show that the study was done for 25 EU countries, showing that the dominant PQ disturbances is voltage dip or sag. So means that whenever there's a voltage dip and sag, the number of customers affected is quite critical for industries in Europe. Okay, this is followed by surge and transient. Okay, now more data on data from US. showing you the financial impact. Again, as mentioned, nowadays equipment are semiconductor electronic based. So these equipment are very sensitive to power quality. So as you can see here, in the US, when this data was taken in 2009, the number one industry is the semiconductor industry. They are very prone to voltage leak or power quality. Okay, in Malaysia, okay, this study I think involved Dr. Dalila before this. The study was done by Professor Khalid. He was from UTM. I think everybody knows, or maybe kalau doesn't know, he was a former UTM lecturer. I believe he worked with Dr. Dalila. So this data was taken, a study done by him for Energy Commission that show that in average, the cost of losses interferometry for specific industry due to power dip. So as you can see from this data, the main or the most critical industry in Malaysia is the semiconductor or wafer industry. So every one power quality event, the semicon industry recorded average 3 million. So this is very critical or maybe disturbing figure for industries or investor. Okay, so the industry in Malaysia, even last week I read a report in Singapore, are very concerned on power quality because it affects their equipment. Even just to share, after the PKP, or maybe after the government lessen the control on PKP, now no more PKP, the industry has picked up, especially industry on semiconductor. For information, I was having a discussion with semiconductor plant in Penang. They are saying that the demand for electronic, I say gadget or tools, for cars has increased. So many industry semicon in Penang, they have their orders fully booked for the next 5 years. As you remember, during the PKP, industries are under lockdown. So after the lockdown has been lifted, industry is picking up. So some industry in Penang, they already got order for the next 5 years. Quite amazing. So that's why they are concerned now. How to ensure that during their operation or production, they can be immune, immune to power quality event. Okay, in Malaysia, we have regulatory requirement which cover all, which cover the supply requirement, operation, technical people, chargeman, disconnection, metering, even power quality. So the Electricity Act 1990 and the Electricity Regulation 1994 covers all that. So this is the main document for power quality and all aspect of electricity in Malaysia. So from the Akta Bekalan or Electricity Act, there is a grid code. Okay, grid code means that this is the practices that must be followed for every operation, customer, taking supply from the grid. As I mentioned just now, in Malaysia, the grid is operating at 132 kV voltages, 275 kV, and 500 kV. So if you are working at any of these voltages, the grid code must be followed. So there are elements of PQ inside grid code. I will explain later on. Okay, if you are working at lower voltages, 33 kV, 32 kV is still available but in small area in Johor, and 11 kV. So all the operation, planning requirement, etc., must be referred to distribution code. All these two codes are owned by the Energy Commission or ST. So there are elements of PQ inside these two codes. Okay, so based on these three references, so TNB to ensure compliance to these three regulatory requirements, TNB has published electricity supply application handbook, or we say ESA, ESAH. So inside ESA, actually before that, the objective is to ensure proper process of supply application by consultant, by contractor are done properly and safely. And for PQ element inside this handbook, it defines the requirement for customer to ensure, first of all, to ensure less emission. So we don't want the customer to emit transient. We don't want the customer to emit flicker. We don't want the customer to emit harmonics. So these are the limits to ensure that the emission is must comply to the requirement. So these are very important level requirement to ensure every time requirement is started. So for example, it started very frequent. The voltage must not be distorted or increase, decrease more than 1%. This is very critical. But if the equipment is operated every 2 hours or more, the voltage must not be, I would say, deformed or distorted by 3%. But if the equipment is operated only once or twice a year, then 6% is allowable. Flicker, there are two items, short-term and long-term flicker, PLT and PST. The limits is shown here. So based on voltage, kalau 1.0 is LV, 0.9 is medium voltage, and 0.8 is above 10 medium voltage. And for long-term flicker, 0.8, LV, 0.7, 0.6. So these are very important to ensure, see, the industry do not emit this emission that can affect the other industries. That's the concern now. Some of these PQ disturbances are generated by another customer. So we don't want that to happen. The same goes for harmonics. The limit is given here, 30% at 132 kV. The voltage must not be deformed, distorted. 3% 32 kV, 4% 11 kV, 5% at LV side. So this must not be introduced to the system. Okay, the next element is on unbalance. Okay, this is also very important. So that's why the consultant, the engineers must understand. This is one is to protect their customer requirement. Secondly, is to protect the other customer. We don't want every time steel mill to operate, it introduce unbalance to the customer and to their neighboring side. So we don't want that to happen. Even the case of transient, we want this to have proper protection against transient. We don't want the customer equipment to be damaged by transient due to lightning. And lastly, will be on voltage side. So you can see here there are two standard, IEC 61411, IEC 61434 plus 1 to 3. So these are very, very important to ensure immunity against voltage side. So these are the standard we want customer to comply to protect themselves from power quality. Okay, let me give you an example. I'm almost finishing. This is a very fast example. Okay, to move forward on PQ, TNB has prepared a few guidebook. This example on voltage side. So this guidebook will explain to the customer what must be done. Equipment must follow specification, control protection must be done, overall immunity must be done. So we focus a little bit more detail. So explain to the customer what need to be implemented on their side, and then more detail. And then we explain about use of power conditioner to the customer to protect the equipment, and we go more detail about the wiring requirement for single phase, three phase, and we also in our guidebook we prepare the solution or maybe the additive need to be installed at the customer side. what are the additives to be installed. And then we explain where to install it. Okay? And then some photos to explain location. These are all real photo, real customer in Malaysia with this equipment. And then we talk about the bigger solution, the three-phase solution and product available. Some of these products are in Johor, installed already. And then this is a photo of myself. This was taken long time ago with the customer in Kuala Lumpur. They install the product. So in summary, I've shared just now on power quality, the issues, concern, and in brief, the recommended mitigating measures. So with that, I think I open to Q&A. Let me just exit the sharing.
Okay, thank you very much, Dr. Fuad, for a very fruitful and informative session and for sharing an interesting experience with us. Okay, now we are open for Q&A session. If you have any question, you please unmute your mic and ask the question, or you can write the question on the chat box. Okay. Do you have any questions?
Yes, have some question in the box chat.
Okay, Hassan. Oh, you have right on the chat. Okay. The question is, the question is a power dip issue from TMB. Can the customer claim the losses due to power dip issues?
Okay. Okay. Mr. Lim, are you working with what company in Johor? Just to confirm the area of the plant. Oh, Bukit Raja Kelang. Which company, Mr. Lim?
Msteel.
Oh, Msteel, yeah. I think Mr. Yeah, let me see. Because for information, inside the Energy Commission requirement, we must ensure communication with customer is done immediately. So what we did, Mr. Lim, let me just check. We formed around, I think 200 WhatsApp group for all customer throughout Indonesia. So for Msteel, let me just check. For Msteel, we have Mr. Rama, I think. Mr. Rama is still around. Mr. Rama. Mr. Rama, is he still around at Msteel?
Yeah, he's still there.
Okay. What I do, Mr. Lim, you are, can I know, are you a facility manager at Msteel?
Just an electrical engineer at the building mill.
Okay, can. Okay, what you do, because I'm the administrator for all the group in with customers. So I can put you in. Okay. I can put you in, no problem, because inside the group we have everybody there. Mr. Lim, myself, the TMB grid engineer, TMB controller, grid and also distribution, and we have also our retail officer. So every time you have any problem on the fly, you can post a group. We immediately inform. But importantly, we can expedite the restoration process. So, Ms. Lim, can you just roughly share me your phone number? I put you now. Your phone number 019. What your phone number? Can you share your phone number, Mr. Lim?
017
017
412
412
0857.
Okay, let me repeat. Mr. Lim, 017 412 0857.
5857.
Okay. I put you in because this is a requirement by Energy Commission. Every time we have a problem, not only power quality, Mr. Lim, you have under voltage, over voltage, outages. So the people there are 24 hours. I'm also in the group. We will inform you, and then under the regulation, we must give you a report immediately. So once we confirm the cost, we'll share you the report that you can share with management what is the cost. Okay, that's the first one on information. Okay, on the claim on power quality equal power dip issue. Okay, this again, according to regulation, and also the supply contract that customer signed with TNB, all this power quality is deemed as a EMC issue. EMC means automatic compatibility issue. So when I meant by EMC, this is something system behavior. For example, when lightning strike the power line, I think we have many cases before this in M-Steel in Kelang and Bukit Raja. The system, according to grid code, it must isolate the fault and restore the fault if the fault is non-permanent. But during the whole process, it cause a dip to the customer. That's why, according to Energy Commission requirement, when this is EMC issue, the customer must immune themselves. That's why that's now the standard on power quality is also actually EMC. So for this case, I'll suggest Salim, once I put in the group, we try many times to talk to your management on immunity requirement. So maybe later on we can discuss separately how to convince. But the focus will be on critical equipment because it can immune. Something macam kita bagi vaksin lah. Sekarang kita ada COVID-19. So the vaccine tu memang must be taken by the people lah. Kalau tak ambil vaksin, okay, tapi kita boleh kena, exposed to COVID-19. So my answer, Muslim, the information I will share you in group WhatsApp. You also get from the TNB people. On the losses tu, the answer is this ST kata is a EMC issue. So the only way is TNB will help you to find the right vaccine. Sama ada AstraZeneca ke ataupun Sinovac Pfizer and so on. So we help you to identify the best solution and then where to install the solution. Dekat tangan ke, cocok kat kaki ke ataupun cocok kat mana. So this one we can talk later, Mr. Lim. How best we can help you once you're in the group. I also introduce you the guy who manage Kelang punya customer, Bukit Raja. So we can help you on this one.
Okay, thank you very much, Dr. Fuad, for the detailed explanation, and also thank you for the Lim Benson for the questions. Okay, next I go to the next question. The second question, Doctor, why there is no standard under IEEE?
Okay.
I think because in my class I am teaching all IEEE and IC, so that's why I think the question raised here.
Okay, thank you very much. Actually, they are few standard on Voltasec from IEEE. The first one is IEEE 1100. Okay, this is very, I believe this is the first standard on PQ by a standard body. So IE introduced, you can Google in the web, IE 1100. This is the first one. Okay, this is focusing on equipment immunity. I'm Salim. It's good. I got a copy of it. I can share with you. I got all the copy of the IEEE standard. So IEEE 1100 focus on equipment immunity. So according to IEEE, PQ is also EMC. So Voltasec, it proposed that the customer follow IE 1100. Okay, so this also cover Mr. Lim question. Okay, secondly, Mr. Ramadan, in 2017, okay, I was involved in development of IEEE, 2015, IEEE 1668. The first one, IE 1100. Second one, IE 1668. So the first one, IE 1100. Second one, IE 1668. This is equivalent to IC 61434 or equivalent to SAMI F47. So, Dr. aware about that? IEEE 1668.
1968. Oh.
1668. 1668.
Oh, lama sangat tu.
Tak. Dia nombor dia
Oh,
IEEE 1668 tapi dia
Oh,
develop tahun 2015, 2017, 2018.
oh, latest.
Hmm.
Mm-mm.
Latest one, IE 1668. Okay. According to this standard also, Mr. Lim and Mr. Ravanan, they mention again the word EMC. So according to IE 16, 1668, and also IE 1100, equipment must have immunity. So means that's why we can assist Mr. Lim dekat Bukit Raja how to find the right vaccine. Just analogi saya lah, kita cari vaksin. Maybe kalau tak AstraZeneca, Sinovac, my analogi lah. Maybe kalau tak Pfizer, Omicron bukan, Omicron tu virus. Maybe some solution yang sesuai lah. So the answer is Ravanan, yes. They are actually 1100 is on Voltasek, 1668 on Voltasek, but then they have another famous IEE, dah tahu 1159.
Yes.
Itu definasi untuk apa tu? Untuk harmonics kan?
Harmonic impact on yes,
bukan.
distribution
Tak,
transformer.
1159 ni untuk definasi
2018.
power quality. Definasi power quality. Definasi.
Yes.
And then they have IEEE 519 tu harmonics. Kan IE
Yes,
519
yes.
tu harmonics. IE 1159 tu definition of power quality. So the answer is yes. Sorry, I didn't mention about that. But they are standard. And then standard 2 are almost equivalent to IEC. So dan boleh pakai in TNB also. We sometimes use IC. Kalau IC not available, we use IEEE. But for Department of Standard Malaysia, they prefer IEC. Department of Standard Malaysia IEC. Tapi for us customer, we can choose each one because we put that in our standard, our spec, technical spec, and then when we float the tender, is our own product lah, no problem. Okay, Dr. Saravanan, they are standard on PQ under IEEE.
Okay, thank you, Doctor. Next, we go to the third question. Dr. Fuad, sorry if missed the information, but can we get access to the TNB guided book about the Voltasek solution that you showed just now? And if yes, where I can get it?
Okay, Puan Nazira bekerja di mana, nak confirm balik? Relevant.
As PhD students. Miss
Dekat
Hazir.
mana bekerja? Oh,
UTM.
Oh, student full time.
Yes, full-time student. I'm a PhD student.
Okay. The guidebook ni currently is under revision. The previous guidebook is 2018. Okay, but give me another maybe 2 months because the new version is coming out. Nanti I will share the link to Dr. Tadila, the new version on Voltasek solution, because why it keep on changing. The solution is being developed by many I would say consultant. Previously in 2018, there are in the book there are around 20 solutions, but as the last two years, there have been more and more solutions being developed by experts and being installed in Malaysia. Just to share, one customer in America installed a new product on Voltasek, and for the last 2 years, they experienced zero. So this new guidebook, this new product is not documented inside the guidebook. That's why TNB need to revise the guidebook so that customer can be aware. There are many solution or vaccine available to manage Voltasek.
Okay, thank you.
Maybe we share next 2-3 months. Total the link.
Okay, thank you, Doctor. Okay, any more questions?
Hi, Dr. Fuad. Good afternoon. I have a question.
Yes.
Actually, I'm a contractor for LRT Line 3. We are doing few stations. Okay, previously we also involved in LRT Line 2. So now, when this job is been awarded, they never implement about this EMC compliance. But now, all our equipment, all our panel, all our sensors, they said must be a EMC compliance. So it's a requirement for all our LRT substation, 33 kV and 11 kV. So, but just wondering, previously when because this is line 3, previously when they do line 1 and line 2, how they mitigate this? There's no mitigation or they are doing it?
Okay, Let me see. Okay. Actually, I'm liaising with one guy. Let me see. As mentioned, we have a lot of communication group with customer. Let me double check. Maybe you know him. Okay. You are the contractor. Okay, agree. But operation side, let me double check. Operation side.
We actually liaise with the consultant from MRCB. I'm not sure
Okay.
if
Okay.
you or Prasarana. There's one consultant. They engage a consultant to guide us.
Okay. Okay. They propose what AMC to be protected, Mr. J?
They
What
said there's two
EMC
requirements,
element?
but it's very new to
Okay.
us, so we also exploring about this. They said number one, the com- uh, the sensitivity of equipment accepting other interference. Second one, the equipment's own interference, emitting own interference to outside. So they said all the equipment sensors all must comply to this.
Okay. Okay. It's true.
Is TNB's new requirement, or only for this station are they doing it? That's my.
Okay. Okay. First of all, for EMC, there are 3 levels. Okay. The one that I've experienced now on the Voltasec, the harmonics, these are the first level called low frequency. Low frequency means that this is an event less with frequency less than 9 kilohertz. Okay. For TNB, we notice that this is the most critical EMC issue for customers. That's why inside our handbook and guidebook, we mentioned the customer must have immunity emission control on this low EMC. Okay, the one you are mentioning is on the medium and high frequency EMC. Okay, for the high frequency is more I think 140, 150 kilohertz etc. That's the medium, and then the highest is more than let me see, more than few megahertz. Okay, so that one too, it's not from the MB, it's from your equipment requirement. It's important because the okay, even for IEEE, there is a committee on EMC. Okay, Dalila, so far saya involve IEC PES kan.
Yes.
PES ni Power Engineering Society, it focus only 50 Hz. But for this other group, EMC ni, it focus on more than kilohertz. So I'm also part of this committee. I'm members. Okay, Mr. J, the requirement tu is critical for your equipment. Is the idea is that the EMC, because EMC ni dia banyak level kan. So for TNB, our EMC on 50 Hz. That's why people talk about EMF and automatic field to all 50 Hz. But for the PQ event, dia not more than 9 kHz. Itulah PQ event. Kalau EMF, magnetic field kan, kita stay bawah power line, that's considered EMF. That one is only up to 50 Hz kan. But when exposed to power quality, transient, harmonic, the limit is up to 9 kHz. Up to 9 kHz. So kalau more than 9 kHz to 150 Hz, is the medium third EMC. I believe kalau more than 150 kHz to 1 megahertz is high frequency. So means that, Mr. J, so this is important requirement of EMC. Yes, I will say yes, but it's not from TNB. It's from the consultant and the equipment manufacturer because they don't want the equipment to fail at the time there is this high frequency EMC. Yeah, so yes, kena buat lah.
Okay. So it's not from TNB lah. It's from the consultant. Maybe they are putting it this requirement to be EMC compliant.
Yes, because even in factories, some factory, I'm not mention the name, So we impose our EMC level, which is less than kilohertz, but the consultant has imposed on the medium frequency. So means that it's relevant, but not from TNB. It's from the consultant.
Understand. Okay. That's why we need to send all our equipment now for EMC test and get certified. Then only we can install in our LRT stations.
Okay. I give you a good example, Mr. J. Our handphone, Our handphone, I'm not sure. Our handphone should be EMC compliant, kan? Correct. Our handphone. Okay.
Yes.
So
I think it depends if Apple maybe EMC compliant China from
But
Depends on
AMC
that. But in best refer to. I'm sorry if I mistake. If I interrupt. My name is Noriza. I'm the consultant electrical engineer. So, if I may add, inside the ESA TNB guideline book version 3.1, at the appendix 7, there is a declaration of electromagnetic compatibility compliance there that we have to get, that we have to submit to the TNB. So I'm referring to my part of work is designing electrical for given a building project. So once I get the maximum demand, this form I was supposed to fill up, but I am Muhammad Faisal. As far as my experience in this field is not that long, but I believe most of the equipment that I install for my building, most of them are EMC compliance because it's the equipment, the brand that we propose for the building project, nearly all of them are based on the JKR standard. As we all know, JKR standard based in JMAL checklist is they already lined up according to what are the compliance that we need to follow. So if back to Mr. J just now query before, is it a new one or old one? I think it's already inside the standard, Malaysian standard already. Perhaps the consultant that involved before this might experience like me, where we do not particularly concerned about declaring the EMC because most of the brands that we propose for projects, either we got it from the what JKR checklist already stated there.
Okay. Muzaffar, okay,
Okay.
thank you.
That's all from my part.
Okay, terima kasih. Okay. Okay, what just now Mr. J and myself were discussing about different level of EMC. So Mr. J, the one for LRT requirement tu is EMC level 2 or 3. So I think you proceed with your consultant because it's also important. As you know, the EMC concern is that on the EMC means automatic compatibility. We want that the equipment at LRT to be compatible with the environment on the high frequency side. So I think boleh proceed because it's a EMC requirement under IEC and IEEE. Okay, the one Puan Nuriza mentioned ni is on supply application JKR. Okay, JKR ingat tak siapa tu Puan siapa? Tador Dalila ni. Last time JKR ada siapa wakil JKR dekat group PQ gitu kan? Dah pension lah.
Hamzah last time and I think
Saya Nurita.
Tak yang dulu kita ada myself Dr. Dalila ni part of SIRIM PQ committee kan?
yes,
Last time
Hamzah last time.
Okay. What happened Puan Nuriza is that SIRIM committee usually appointed by Jabatan Standard Malaysia to study kan, analyse ke ataupun enhance standard on PQ.
Okay.
Not on PQ, other things lah. So the idea is that all respective party ni go back and standardize in their respective company or department lah. So step by step pertama Arya Hamzah ada buat tak buat Dr. Dalila tak pasti Tapi anyway, the idea is that Puan Nuriza, that now is under Jabatan Standard Malaysia, they standardize the standard. Okay, macam for TNB mention our concern is on low frequency standard EMC. So Puan boleh cari kat Google less than 9 kHz tu memang TNB concern because bukan pula our concern is that 9 kHz tu dia travel on cara conductance lah through our network. So kita nak ensure the customer tu tak exposed to this 9 kHz EMC from neighboring customers sebagainya. Itu our concern. So dalam ESA tu dia fokus EMC level 1 yang 9 kHz below. Yang Mr. J mention tu is on the other EMC. Dalam ESA, even dalam distribution code pun grid code dia fokus on EMC level 1. Pasal TNB ni konduktor mengalir, konduktor data tu mengalir. So apa yang mengalir atas konduktor. So yang LRT tu lain sikit.
Okay.
So bila dalam ESA tu betul, tinggal tu betul semua.
Okay, noted. Alang-alang tu saya nak tanya sebab saya ada buat permohonan LV untuk satu projek PPU ni dekat Melaka. Kemudian saya compare dengan dokumen yang saya perlu submit untuk permohonan supply bagi normal substation dengan dokumen yang saya submit untuk permohonan PPU. Jadi saya just nak tanya, dua-dua kes ni memang saya kena submit ke yang Appendix 7 Power Quality Declaration Form ni?